What is a pointer? How are they implemented in C? In C, a pointer is a variable that stores the address of another variable. Pointers are used to store addresses because they are typically smaller in size than the variables they point to, and can be used to manipulate the value of the variable indirectly. Here is an example of how to declare and use a pointer in C. Here we have the integer x, which is equal to 10, declaring a pointer to an integer, storing the address of x in the pointer, printing the value of x, the address of x, the value of the pointer, and the value pointed to by the pointer. The output of this code would be this: the value of x, the address of x, the value of pointer, and the value pointed to by the pointer. In this example, we declare a pointer to an integer and assign it the address of the variable x using the ampersand operator, which returns the address of a variable. We can then use the asterisk operator to reference the pointer and access the value stored at the address it holds. The asterisk is important when you're accessing the value. Without it, you'll just have an address. Just imagine it being a star. A pointer is just a pointer, but if it refers to something like constellation, you can actually get something from it. In essence, a star, aka the asterisk, means that it refers to something which it points to. We can also use the asterisk operator to change the value of x through the pointer. Here we can see the example. How does a pointer differ from normal variables? There are several key differences between pointers and normal variables. Pointers store addresses while normal variables store values. For example, an integer point might store the address of an integer variable, while an integer variable will store an actual integer value. Think of the normal variable as a landmark, Mondstadt for example, and the pointer as an address to the landmark. A waypoint. You can use a waypoint to get to Mondstadt, instead of just going to Mondstadt directly. But that waypoint is not essentially Mondstadt, it just brings you to Mondstadt. Pointers must be the reference to access the value they point to, while normal variables can be used directly. For example, to access the value of an integer variable x, you can simply use x, but to access the value of an integer pointer, you must use star pointer, which I explained earlier. Pointers can be used to manipulate the value of the variable they pointed indirectly, while normal variables can only be used to store and access values directly. Pointers are basically using artifacts to change the stats of your characters indirectly, while normal variables are like your base stats that you change directly by leveling up. Pointers can be used to dynamically allocate memory during runtime, while normal variables are usually allocated on the stack or the heap at compile time. Think of it like the charming Lisa who can dynamically allocate time to tease you during work, while the Bisining Guang usually allocates time to tease you if she could fit it in her schedule. Pointers can be used to implement data structures such as linked lists and trees, which are difficult or impossible to implement without using pointers. Determining which sequences of events lead to which would be hard without pointers. Pointers can be more difficult to use than normal variables, because they require careful management and can lead to bugs if not handled correctly. What are the benefits of using pointers? Pointers allow you to pass large amounts of data to functions more efficiently, because they only require a single memory address to be passed, rather than a copy of the entire data. Yanfei would appreciate it if you were to give the document only concerning your legal issue, instead of your whole backstory. Pointers allow you to dynamically allocate memory during runtime, which can be useful in situations where the size of the data is not known beforehand, or when the data needs to be resized frequently. Pointers allow you to implement data structures such as linked lists and trees, which can be more efficient and flexible than arrays in certain situations. Pointers can be used to implement complex algorithms and data structures that would be difficult or impossible to implement without them. Think of going without pointers like the Aratake gang without Kikushinobu to direct each member. What are the dangers of using pointers? As I've said before, pointers can be more difficult to use than normal variables, because they require careful management and can lead to bugs if not handled correctly. Pointers can make code more difficult to read and understand, because the relationships between pointers and the data they point to can be complex. Pointers can lead to security vulnerabilities if not used correctly, because they allow direct access to memory addresses and can be exploited by attackers. What use cases would benefit from use of pointers? Aside from the dynamic memory allocation, implementing data structures, passing by reference, performance, there is low-level programming. Pointers can be used to directly manipulate memory and hardware registers in low-level programming tasks. What are linked lists and how are they implemented? A linked list is a data structure that consists of a sequence of nodes, where each node contains a data field and the reference, links, or pointers to the next node in the list. The list is implemented as a global variable head that points to the first node in the list. The last node in the list typically has a link to a null value, indicating the end of the list. Linked lists are useful for storing data when the size of the data is not known in advance, and when the data needs to be able to change size during execution. They can be used to implement stacks, queues, and other data structures. One of the main advantages of linked lists over arrays is that you can insert and remove elements from a linked list without the need to move the elements around in memory. In an array, inserting or deleting an element requires shifting all of the elements that come after it, which can be time-consuming. Think of it as being able to move your furniture inside your house normally instead of having to remove every piece of furniture and fixing the order in which they are placed back inside the house. Here is an example of a simple linked list structure in C. This code defines a linked list with 3 nodes containing integer data. The nodes are created using the malloc function, which dynamically allocates memory in the heap. The data fields of the nodes are then set up and the next pointers are used to link the nodes together. To traverse the list, we start at the head of the list and follow the next pointers until we reach the end of the list. In this example, we print the data of each node as we go. This is just a simple example of how you can use pointers to implement a linked list in C. There are many other operations that you can perform on linked lists, such as inserting and deleting nodes, reversing the list, and more. Just think of the perpetual mechanical array as an example of a linked list of problems. It can turn into a cube, a sword, a rocket, and a bunch of small pieces of itself, depending on the combo or phase that it's going for. Now, how to insert elements, delete elements, initialize, and concatenate linked lists. Inserting elements into a linked list. To insert a new element into a linked list, you need to allocate a new node in the heap, set the data field of the node to the value you want to insert, and adjust the next pointers to the existing nodes to include the new node. This function takes a pointer to a node and a value as arguments, and it creates a new node with the given value and inserts it after the given node. Just think of it as adding another character to your party. To insert a node at the beginning of the list, you can set the next pointer of the new node to the current head of the list and then update the head of the list to point to the new node. It's like adding a new action to the start of your combo sequence. Deleting elements from a linked list. To delete a node from a linked list, you need to adjust the next pointers of the surrounding nodes to skip over the node being deleted. You also need to free the memories occupied by the node using the free function. Here is an example of a function that deletes a node after a given node in a linked list. This function takes a pointer to a node as an argument and deletes the node after it by updating the next pointer of the given node to skip over the deleted node, then frees the memory occupied by the deleted node. Just think of it as removing a character from your party, and now you have space to add a different character or play as just 3. To delete the first node in the list, you need to update the head of the list to point to the second node. Just think of it as skipping an action from your combo sequence to end the sequence early. Initializing a linked list. To initialize a linked list, you need to create a head node and set its next pointer to null. You can also set the data field of the head node to a default value if desired. Here is an example of a function that initializes an empty linked list. This function creates a new node in the heap and sets its next pointer to null, indicating the end of the list. It then returns a pointer to the head of the list. Just think of it like Sai's schedule. Initially, it's all sleep, but you can add some missions into the schedule and remove some later. Concatenating linked lists. To concatenate 2 linked lists, you need to find the end of the first list and set the next pointer of the last node to the head of the second list. Here is an example of a function that concatenates 2 linked lists. Just imagine it as combining the combos of 2 characters for a longer combo.